All right, so now we're talking about some of the things that after you set, how is the ventilator going to work? How's it going to operate? And here I'm going to talk a little bit about the 3 T's, or the things that tell a ventilator to turn on and deliver breath. So that's trigger. I'm also going to talk about what's the target, what are you looking for, and then what terminates the breath. And so these are the 3 T's that we look at. And in volume control, if it's an assisted breath, then that's patient triggered. A controlled breath is machine or vent triggered. And then when we talk about our target and our termination, we're trying to get to a volume, and we're trying to give enough flow over enough time to reach that volume and then exhale to have the vent be able to shut off. So graphically speaking, let's talk about just the basics of what happens with a ventilator and how air goes in, okay? So this, I'm going to talk about flow or air flow, and I'm going to take a x-axis here on time. And I don't want to overwhelm anybody with graphics here. What I really want to do is just show you what happens when somebody takes a breath and what happens with the air. So here we've got flow, and this is in liters per minute. And I'm just going to make these scalars up to about 60. These are going to be 10. 60, be about 30 here. Okay. So what happens is, if there's zero flow, here's this baseline, no flow state, no air is rushing in. Now let's say the patient is on assist control mode and they take a breath and they start a breath. Once that patient starts a breath, the ventilator opens up a flow chamber, air rushes in from the ventilator through the tubing, down the ET tube into the patient's lung, and ET tube is endotracheal tube, right? So this would be what would happen in just a basic square wave form. Flow rushes in, it continues for a while, and if you have a set flow rate and you give it for a certain amount of time, then you can come up with a certain volume, which is your target, and then the breath will shut off, and then flow can come back and patient can exhale, all right? So that's the most basic graphic I can do for flow, is that we've got flow running in and then the patient starts to exhale. Every now and then you'll see a pause some of the time on the ventilator where we get no flow for just a second before the patient starts to exhale, and then returns to zero or no flow state before the next breath. All right, so this is just the simple thing of what happens with airflow. Now, if it's a machine-generated breath or a controlled breath, a certain timer goes by and it says, oh, I'm due for a breath every 4 seconds because that's my respiratory rate, and the patient is on the ventilator and 4 seconds goes by and the ventilator knows, oh, it's time to give a breath that will deliver airflow in this fashion. So, simultaneously, if this is going on, I also have some other things going on. We talked about previously that the airway pressure was going to be a variable. We don't control for that if we're controlling for the volume. If somebody is on a volume controlled mode of ventilation, then the airway pressure becomes variable, and that's what we watch as a variable. So if you can imagine this breath happening, right? At the same time, I could have airway pressure, and over here, I could have volume in ml, right, going on at the same time. If it is a patient-initiated breath, let's say we've got the PEEP set at 5, right? Patient takes a breath. That often can be seen here as a little bit of a negative deflection of pressure. And this pressure will go up and then come back down, and come back down to the PEEP of 5 that you've registered. All right, sometimes with a square wave, this pressure is going to look just like this. A little bit of negative pressure to start a breath, and then go up, and then come back down to about that PEEP that you set. Okay, so that's what airway pressure will look like. Here, if these are increments of about 100 cc's each, and this is time, once again, the x-axis on all these are time, and these are the same breaths happening at the same time, then I go up, my tidal volume is set for 400, so my flow is delivered for that exact amount of time that's going to deliver 400, and then I'm going to exhale. So this is all happening at once, and that's the graphic representation of what's going on in volume control. All right, so at least that's what's going on. If this is a controlled breath and it wasn't patient initiated, you don't get that negative deflection. The patient never, tried to inhale on their own. This is just basically going off of a timer because 4 seconds has elapsed, because we should be taking 15 breaths per minute or a breath every 4 seconds. And that's what goes here. This would be a controlled breath. So that's the graphic representation of the difference between an assisted breath and a controlled breath. And then we can sometimes change these flow parameters and make them look a little bit different, and to make it a little bit more comfortable for the patient use these other modes. I wouldn't worry about that too much for right now. All right, last but not least, I'll talk a little bit about just airway pressures and some of our normals that we look for. We'll be talking about airway pressure significantly later, because in ARDS patients, we can often have problems with the peak airway pressure and what we call a plateau pressure. So I'm just going to talk about that briefly when it comes to vent terminology of what a peak inspiratory pressure and plateau pressure are. All right, so we've got our graphics here, right? Flow's going in. And over here, this peak pressure up here, or the highest amount, is what we call the peak airway pressure or peak inspiratory pressure. Now, I had said a little bit ago, sometimes we have this pause and flow at the end of the breath, and sometimes that can be seen graphically here, where the flow goes in, and as this is happening, pressure starts to increase, and then we reach this no flow state, or what we call a pause, and we get a little bit different pressure when we remove that airflow. And maybe it happens here and then comes back down to the 5 of PEEP that you set. So that would be if we have a PEEP of 5 here. Once again, here's the airway pressure. Now we can also do this on the ventilator by doing what's called an inspiratory pause or inspiratory hold. And we hit a button, and after inspiration we can hold it and stop flow for just a moment to see what's going on. When that happens and we have a no flow state, we call that plateau pressure. So that's the difference between the two. And roughly speaking, if we remove airflow from the situation, and this is a significant drop from the peak pressure to the plateau pressure, we're probably dealing with airways obstruction. We'll be talking about that a little bit more in detail, but something like asthma, or maybe the patient's biting on the tube, there's a problem with airflow. And if you remove flow, then you remove a lot of this pressure, because you're removing a lot of that resistance. So that's the difference between a peak inspiratory pressure and a plateau pressure. What happens is ARDS, or in ARDS, you stop flow and the pressure still remains high. And the difference between the peak inspiratory pressure and the plateau pressure is probably less than 5 even. And so you're dealing with a problem with lung compliance, and the lung isn't very stretchy, it's very overwhelmed with illness acutely, and it doesn't want to extend, and that's where the PEEP comes in handy.